In this video, we are going to talk about problem solving using rational equations, and these types of problems are ones that involve work. And so for the work problems, I want you to think about this sort of scenario here where you have x over a plus x over b, and that is equal to 1, because ultimately that's what our work problems are going to look like when we set them up. So let's consider this problem. Jake can mow the field in 5 hours, and another person can mow it in 3 hours. The question is, how long will it take them to mow the field together? So let's say they're each mowing at the same time. Now, your gut may first tell you, oh, it's going to take them 4 hours. That makes sense because that's between the two, right? But you have to remember that this other person, if they did it totally by themselves, could do it in 3 hours. And so if Jake is helping this other person, then it should cut this time down so that it doesn't even take a full 3 hours. It should be less than 3 hours. So I'm going to say x equals how long it takes to mow the field together. So time to mow together. And we of course are going to put this in hours because the problem is already done in hours, okay? And there are no other unknown quantities for this one, so it's just how long does it take for them to mow together. So here's what I want you to think about. Again, I like using these tables because it helps me organize my thoughts and come up with the equations that we're going to use. So the question first is, how much of the field can Jake mow in 1 hour? Knowing that it takes him 5 hours total, how much can he do in 1 hour? How much of the total field? Well, the idea is that he can do 1/5 of it in 1 hour, knowing that if you multiplied by 5, which is the total time, 5 over 5 would equal 1, and that's the whole field. Similarly, the other person can mow 1/3 of the whole entire field in 1 hour. And then the question is, how long do they work together? Well, that is x. Okay. So this is the rate for 1 hour times however many hours they work together. If I multiply these two together, I get x over 5, because 1 over 5 times x over 1 equals x over 5. And that is how much of the field Jake does in these x hours. Similarly, this other person, 1 over 3 times x over 1 would give me x over 3, and that's how much the other person does in the x hours that they work together. The goal is, if I add these two pieces together, hopefully what we get is we get equal to 1 because, not x equals 1, but we set the problem equal to 1 because they will finish up the whole field. Okay? So that means I take my x over 5 plus my x over 3, and I set it equal to 1 because here's how much of the field Jake completed. Here's how much of the field the other person completed, and that equals the whole entire field, which is 1. Now we're going to solve. What's my LCD here? 5 times 3 is 15. So I'm going to multiply both sides of my equation times 15. When I multiply this side of the equation times 15, remember both parts get multiplied by 15. So 15x divided by 5, well, 15 divided by 5 becomes 3, so that's 3x. 15 times x over 3 becomes 15x divided by 3, so 15 divided by 3 is 5, so that adds to 5x. And then on the other side, 15 times 1 is 15. Combine your like terms here, and we're going to solve. So x equals 15 over 8, but again in this problem, although I am fine with an improper fraction, it does make sort of more sense to say 1 7/8 hours. Now, does that make sense? Check the proposed solution in the original wording of the problem. Does that make sense? Well, let's go back and look at it. Okay. Remember, Jake could do it in 5 hours if he did it all by himself. The other person could do it in 3 hours if they did it all by themselves. But we said they're going to work together, so it should take less than 3 hours if they work together, because this other person, they're just a whiz on the mower. They can do it all by themselves in 3. So it should be less than 3. We got an answer of 1 7/8, and that is less than 3, so that does make sense for this problem. Okay. All right, we've got one more type we're going to look at before we're done, but for now, keep up the good work, and we'll see you in the next one.